So what are irradiation or the details of radiation? So that is a complementary part of radiation, irradiation. And now we'll look at some details of sigma, which was emissivity. Then we have we'll also go into the value of this epsilon, sigma, absorptivity, tau, reflectivity, etc. So we'll look at these things in this video. So we already know that EB is the maximum emissive power, and that is the emissive power of a black body. So black body is defined in that way that it can emit all kind of radiations, and real bodies cannot emit all kind of radiation, so they have some limitations. That limitation is defined using this epsilon or emissivity. So emissivity of a black body is 1, and emissivity of real bodies is less than 1, greater than 0. So EB was the black body emissive power or maximum emissive power, depending on the temperature Ts, surface temperature. Then we had E, that was the emissive power of real bodies, and since we are saying them as power, that's why the units will be watts. Okay, or watts per meter square, maybe that's more correct. Watts per area. So emissive power we know is a temperature dependent, and it's raised to power 4. And technically, because I said it's watts per meter square, technically it's not power, it's technically flux. Flux was the energy rate per area. That's how I defined flux. Flux was defined as Q dot, that was the energy rate upon area. This was flux. So this is actually flux. This is emissive flux. Okay. And now let's come to sigma value, that is Stephen Boltzmann constant, and the value of this is determined by some experiments. Value is 5.67 into 10 raised to minus 8 watts per meter square into Kelvin raised to 4. Here the Kelvin and degree Celsius are not exchangeable. They cannot be replaced by each other, which I explained using the value of K, where the units was watt per meter Kelvin, or we can also write them as watts per meter degree Celsius. Because the power was 1, that's why we can change them to Kelvin and degree Celsius, but over here the power is 4, that's why we cannot replace directly with Kelvin with degree Celsius. So this value you must remember. Now the heat transfer rate, so this was flux, that's why heat transfer rate Q dot will be equal to the area times emissive power of real bodies into sigma into Ts raised to 4. And what is irradiation? So radiation is whatever we emit. Irradiation is whatever we receive. Whatever our body receives is called as irradiation. So that is incident radiation. Irradiation is incident radiation. Now incident radiation, so if we are receiving some X amount of radiations, it is not sure that we'll absorb all the radiations, whatever we are receiving or our body is receiving. So there is a factor alpha which is called as absorptivity, given by some Kirchhoff's law. So Kirchhoff's law gives the value of alpha absorptivity, and now the incident radiation Q dot. So whatever Q dot happens due to incident radiation is given by Q dot is equal to A into A into alpha into sigma Ts raised to 4. because here we are involved the absorbivity. Now when we are Kirchhoff law assumes one thing. It's assumed that the alpha is equal to epsilon. That means the absorbivity and emissivity are equal, and that is the case for a gray surface. So if you are asked what is a gray surface, remember gray surface means the absorbivity and the emissivity are equal. And so that's all. Let's now look at these other terms which I explained or which were there, or better keep them for next video. So as of now, this is what irradiation involved. Okay, thank you.